All right, so, whoops, this is not the question I wanted. That's my other class. Okay, so let's try it. So it's 4x. Whoops, not even on the screen for you, huh? There we go. 4x minus y equals 7. All right, there we go. So we're supposed to graph it. So what's the first step whenever we graph something? This is the quiz. Get y alone, exactly. This is the quiz question. So we get y alone. Here's the wall. Y is saying, I want to be alone. So we grab that 4x and we just jump it to the other side. And what happens whenever something jumps to the other side of the wall, or the equal sign? The sign in front of it changes. What's in front of the 4x right now? Nothing, which means plus. When it jumps over, it'll become minus 4x. And what's in front of the 7 is plus. And don't forget the minus is still in front of the y. Is that good? So the sign in front of the 4x changes from plus to minus when he jumps it over. Everything else has remained with the same sign in front, right? The y still has negative in front. The 7 had nothing, which is really positive. That hasn't changed. And now, y's not quite alone. What do we got to do to finish getting y alone? Divide by negative 1. And you know, that just switches all the signs, huh? If you want, you can just change all the signs without doing anything. That's fine, too. So it's just 4x minus 7. All right, so we're ready to graph. So now when it comes to the graph, where do we start?
At the y.
Yeah, the number out off to the right, that's the y-intercept, huh? Start down 7 in the middle, huh? So we do our graph. 1, 2, 3, 4, 5, 6, 7, like that. Down 7 in the middle. Okay, good. And now, that's our first dot, down 7 in the middle. How do we get our second dot?
Oh, 4 over 1.
Yeah, you make this 4 over 1. Rise over run, huh? Go up 1, 2, 3, 4 over 1. Rise 4 over 1. Connect the dots. Whoops, mine's a little curvy, but there we go. Now, that was C, huh? Yep, looks like it. Want to see back here. That was graph C. Going up to the right, like that. Starting from it starts down in the middle, goes up to the right. That is what we have on our screen. Down in the middle, up to the right. Good. Questions on that one? We happy with that? We good? All right. 4.1, 5 to the third power. All right, what does it mean, that little number in the upper right-hand corner? It's an exponent? Yeah, exactly. It's an exponent, a power, whatever you want to call it. And what do you do with it?
Multiply.
Exactly. Yeah, and you can use calculators. Again, you can use calculators on the exam, and you can use a 3x5 card. Anything you want in there. Yeah, 5, 5, 5, isn't that 125? Wait, I should make, it says type your answer as a product. Don't simplify. In other words, what they want on this one is they just want you to write 555. Yeah, they don't want you to actually get the 125 answer. I'll cross that out. Don't do that on this one anyway. Remember what you do if you're unsure, because that's kind of weird. I think that's kind of weird. What do you do, like if you're looking, you go, I don't know, they want me to do the answer, do they not? Remember how to find out what they want? I mean, I guess the blue line kind of says it, but it's still a little confusing. The best thing is click on the question help, show me an example, just jump, enter, jump to the bottom, and you'll see, oh, 555. Oh, they want me to leave it, and then you'll know what they want. So you don't waste your time. Okay, so 6r to the fourth. They want you to write that one out again. They don't care about a final answer. They just want you to write out what it says. So the question is, that 4, which means, repeat something 4 times, what is that 4 on? Is he on like the R and on the 6, or just on the R? Yeah, you guys know it. So there's only just 1 6 and 4 R's, huh? Like that. That's all they want from you. They just want you to be clear that it's not on both.
R times R times R times R.
Yeah. Yeah, that's all that means. Yeah, these are supposed to be dots. Well, you don't have to. If you put nothing in between, it means times. Yeah, you don't have to put.
I had to put it the other way.
Yeah, either way, dots or no dots, it's okay on that. Yeah, good. So you guys know that. Okay. Do you guys know what is b to the 0 power? Do you know that? Yeah, it is. You're right. It's just 1. It's just 1. That's kind of a funny rule, huh? Does it?
Is it just 1 or just b?
Yeah, it's just 1. It seems like it should be b in some ways, huh? But it's actually just 1.
So no matter what's right there, if it was a 7 to the 0 power.
Yep, exactly. If it was 7 to the 0 power, it would be 1. If it was 2,516 to the 0 power, it would be? Yeah. Isn't that strange? Doesn't it seem like they're just making it up as they go along? When you look at that, like, really? I mean, why is that 1? Hold on, in about a half an hour after we get some other rules, I'll go back and I'll show you that that actually has to be that way. Well, it's more complex, but show it, but yeah, these are kind of silly questions. H to the 1, and H is, so they just want you to plug in 21. 21 to the 1 is just 21. Yeah, so if you have a first power, it just means one of them. But if you have a 0 power, it makes the whole thing into 1. Everybody see that difference? Right? So yeah, first power, it's just 21, huh? Answer just 21, nothing more. Yeah. So yeah, so x to the 3rd, x is 2. You guys know what to do, right? Plug that 2 in, then just use your calculator, or by hand, or whatever you want to do. So plug that 2 in. Remember, whenever we plug into a formula, put parentheses around what you're plugging in. So it's going to be 2 times 2 times 2, 3 times, right? And they're multiplied, not added. It's not 2 plus 2 plus 2. It's 2 times 2, 4 times 2, 8, right? Good? Just like that? All right. All right, so 165 minus s squared. S is 7. So plug in that 7, and then just use your calculator, you know. So it'll be 165 minus 7 squared, like that, right? You put parentheses around things that you plug into formulas. So 165 minus, and which calculator say 7 squared? And maybe you just know it, 49, right?
116.
Is that what it is, 116? Thank you. 116? When you subtract those? Questions I can answer on that? Is that making sense? So we just square the 7, 7 times 7, 49, and then just subtract on that. All right. Do you guys remember the area? It's the one area, right? Yeah. Area of a circle formula. Does anybody remember that one? Good. Pi r squared. Yeah, pi times radius squared. Exactly. Exactly. Yeah, so put that on for the 3rd exam, not for the one we take Monday. Yeah, radius is half diameter. Yeah, so they have the r right here in the picture, huh? There's the r, and they're telling me the r is 46, and they're telling me 3.14 is pi, right? So 3.14. That's right, we're coming up on Pi Day. If you want to be extremely nerdy, March 14th. I mean, it's officially called Pi Day. San Francisco, they always have a parade for Pi Day. March 14th. It's true. So next month. Well, they probably do that too. They mean the number pi, but I'm sure they bring out physical pi as well. That's what they do. All right. So there it is. So I just plugged in the pi, and I plugged in the r, which is 46, into the formula. And then it's just use your calculator from there. Does that make sense? So 3.1, whoops, I'm kind of getting scribbly all over the place here. So 3.14 times 46 times 46. Hit the buttons on your calculator, and please let me know what you get. I'm betting like 6,000 or 7,000. Maybe I'm too high. Is that 2,500? 2,000? No, it's around 6 or 7. Oh yeah, so I'm right. 6644.24. Anybody else getting that? Yeah. All right, good. And how far do they want me to round? Type an integer or a decimal. Yeah, I guess they just want that straight decimal, just like that. Is that good on that? So make sure that I would really encourage you to bring your calculator with you to class and just be using it to make sure it's doing what you want. If you have any trouble, grab me after class. Usually 10 seconds. I can help you get your calculator in the right mode or whatever it needs to be and help you with that. So we all good with that? Make sure you can calculate these things. All right. Does anybody know, this is totally weird. What does it mean to have a negative up there in the power zone. It is, but it's because it's a fraction, which will be a decimal eventually. Yeah, negative powers flip the thing. Isn't that weird? Yeah. Negative powers flip it and make it a fraction. So in other words, negative power flips to the denom, and then power becomes positive. Does that make sense? So negative powers flip the thing, and then the power becomes positive. And then you just finish it up like normal. So what do I mean like normal? Well, now it's 1 over 10 squared. So just the bottom is just 10 times 10, right? Which is 1 over 100. And that's it. Oh, actually, you know what? They said write using a positive exponent. Maybe they want me just to stop right there, I think. Yeah, so they don't actually want me to go any further. Because they said write using a positive exponent, power. So there it is. There it's written with a positive power. They don't want me to actually finish the answer on that. Yeah?
On the 1 over 10, is that a plus or multiplication sign? Like circle part?
This is a plus right here.
The plus or
This right here is a plus 2. Is that what you're talking about? This one?
yeah, so I'm. No,
Yeah, so that negative power changed to become a positive power.
Oh, so in all reality, it's 10 to the second power.
Yeah, it's just regular 2. I'm just showing the plus for extra emphasis.
Okay.
But you're right, it's just 10 to the 2. Yeah, exactly right. Has everybody seen that? Yeah, and I just wanted to show the negative power, flipped it, and then became positive. You don't need to show that plus sign. Yeah, it's just 10 to the regular 2. That's right. Yeah.
Why?
Good question. I like that you want to know why, but I have to keep it a secret for now. I'm just kidding. Let's get a couple more rules, and then I'll be able to explain like the zero power thing and this weird thing. A couple more rules, and I'll be able to put it together. Well, I'm glad you want to know why.
What answer do you put in here?
Yeah, I think on this one they just want this. And then in a minute, they're going to ask us to go further with them, right? Is that what they want? Yeah. Yeah, and how you know is because they said positive exponent, positive power. So this has a positive power. So we're good right there. It won't be a problem on the third test because it's multiple choice. You'll just look down and go, oh, they just have the powers there, or oh, they figured the final answer, so I'll hit the buttons on my calculator. You know, you'll have no trouble. You'll just do whatever the multiple choice answers are doing, you know. All right, and if you're ever unsure with Math Excel, click the question help, show me an example. Yeah?
So it says that one part's remaining, so what's the second part of it?
Oh, good question. It probably wants you to do the... All right, so g to the negative 2. What do? What's a negative power always do? Flips it to the bottom, and the power becomes regular. You don't have to write plus. You can just make g to the regular 2. Right? You don't. I'll just erase this. G to the regular 2. Is that good? That's all. That's all there is to do on that one. Just flip it. So negative powers flip things, don't they? They flip them and make the power positive, which is totally weird, and I've given no reason why. What do y'all think? What about the last couple? The last couple had negative powers, and then it flipped to the bottom and became positive. This one has a negative power already in the bottom. So what do you think it's going to do when it has a negative power already in the bottom? It's going to change to positive, but remember, they always flip things, right? So negative powers always flip. If it's regular, it flips to the bottom and becomes a positive power. If it's starting on the bottom, where's it going to flip to? To the top and become a positive power. So basically, negative powers, here's how I think of it. Negative powers are, I just think negative. It's like a person that's in a job. It's a negative job, and they want to jump out of there to some other job they like better. And then they become happy after they make the change. That works. So the negative power, wherever it's at, is unhappy where it's at, and it wants to jump to the other side. And after it makes the jump, then the power becomes positive. So that negative power is going to go, I'm not happy here. I'm going to jump to the top, and after I jump, I'll become positive 7, or just regular 7, in the top. And then that's just it. That's the answer. In other words, it's over 1, but you don't have to, we don't show 1s in the bottom, do we? So I just leave it s to the 7th. You don't need to show the plus. It's just s to the 7th. Does that make sense? If it had started in the top, it would jump to the bottom. It starts in the bottom, it jumps to the top, and then it becomes positive power. Whoops, just erased it. After the jump. It's happy after the change. Does that make sense? That's what negative powers do. They're negative, they're unhappy where they're at, they jump to the other side, become positive. So on this one, is that power positive or negative? Is it happy or sad? Is it positive or negative? It's happy where it's at, but they specifically want me to make it unhappy. They say, write it as a negative power, negative exponent. So if it jumps to the other side, what's it going to become? Unhappy, right? So basically, whenever you jump the thing to the other side of the fraction, the power changes from positive to negative or negative to positive.
Like if it says, right, with all positive exponents and you have negative exponents on top, it goes over to the bottom.
Exactly. Yeah, usually they'll say make the negative one positive. This is kind of a reverse weird question, where they actually want me to make the power negative. But it's the same idea. Does that make sense? Just whenever you jump that thing from one side to the other, the power changes signs, doesn't it? Just the power. Notice 4, there's no sign change in front of the 4, huh? Just the power. Just the power changes signs on that. All right, this probably a lot of you already know. 8 to the 6th times 8 to the 3rd. Hey, can we do multiple choice? We'll pretend it's a test. E's going to be none of the above, like it always is. There we go. So there's 4 answers, like a multiple choice test quiz thing. 8 times 8 is 64, in case you're wondering about the numbers. Anyway, so it's 8 to the 6th times 8 to the 3rd. So everybody, we're gonna take a class survey. So give an answer in your own mind or on your own paper there.
You just gotta add.
Feel free to talk it out with those around you. Are you ready to vote? How many say answer A? Nobody likes A. All right, how many like B? Chunk like B, maybe 10 or 15. How many like C? Nobody likes C. How many like D? About almost the same, or a little bit more than B. So it's B or D. It's B or D. B or D. They're closely voted. I think D might have got a few more votes. So convince each other. There's a B camp and a D camp. Can you persuade each other?
It's B.
It's B. Okay, why?
8 times 8 is 64, but when you multiply, you add the exponents.
Great. Okay. What is that? That's an argument for B. So she said 8 times 8 is 64, but you got to add the powers 9. Right? So there's an argument for B. We have a D camp argument. Yeah.
It's the same base, so it's the same bases, you just add the exponents, it won't matter if you multiply them.
So you just keep the same base.
And then you add the
And you add the powers. So you agree with the add the powers part. Both of your camps agree with the add the powers part. The only question, the difference between your camps is, do you multiply those bases or do you not? What do you think? Now, what I can do 2 things as your math teacher today. I can tell you the answer. I can say, thus says Mr. Herring. Really, who cares what Mr. Herring says? Other than the fact that I grade your tests. Huh? But really, I mean, in my opinion, who cares? Truth. I'd much rather show you where you yourself would go, oh yeah, that's true. That's not just Mr. Herring's opinion or some math book or math teacher, right? It's really true. Can anybody give me an argument from truth? Why does it have to be one of those 2 and not the other? Yeah.
Same number.
Multiplication signs there for a reason.
Vote that 8 times
Just a
7,
rule?
multiply.
Okay. Let me ask you this, guys.
For the same number.
You know the answer if you think about carefully what it's saying. You really do. What does 8 to the 6th mean? Yeah. 8 times 8 times 8 times 8, 4, 5, 6 eighths, right?
So it is the base.
Okay, and what does 8 to the 3rd mean?
8 times 8 times 8.
3 eighths, right? We all know that. I'm not doing anything. I didn't just show you anything you didn't already know. You knew that. So how many eighths we got there?
9.
We got 6 of them and 3 of them, and they're all multiplied together.
So it's the base.
So is that right then? Of course that's right. That's wrong.
Why is it true?
See that? That's true, isn't it? It's not 64. It's not 9 64s. Is that 9 64s? It's 9 eighths. Now I know you say, yeah, but they're times. Yeah, but this is true, isn't it? Isn't that true beyond any question?
Is that only if they're the same?
I'll explain more details in a second, but everybody agree with the truth here. This means 6 eighths. This means 3 eighths. What do you got? You got 9 eighths, not 9 64s, huh? It's just true. See how math isn't making stuff up. They're just going with what's true. So, yeah, good question. The rule then is when the bases are the same, you don't multiply them. You just add the powers because it's true. Huh? Right? So let me write that out. So when the bases are the same, do not multiply the bases. Just add the powers. That's not just my opinion or any math teacher's opinion. That's the truth, isn't it? That's what it means. See how math just follows the definition of what the thing is? It just follows the truth like a hound dog following the scent wherever it'll go. Math is just following truth. That's all it's doing. So does that make sense then? So when the bases are the same, you don't actually multiply them. Even though you got that dot in there. It's so tempting, huh? You don't actually multiply them because that's not true. You just add the powers on that. We good? All right, so 7 to the 24 times 7 to the 16. So what do I do there? What's the answer going to be?
You just add 6 and 8.
Do I multiply the 7 times 7?
No.
No, you keep the base and you add the power, whatever that may be. Is it 40?
Yeah.
7 to the 40th. That good? Keep the base the same? Because that's what it means. It means 24 sevens and 16 sevens. You got a whole bunch of sevens. You got 47s, huh? All right. When they do that. It totally is. You're totally right. Yeah, okay, because we have 3n to the 7th and we have 3n to the 18th. So really, you just got a whole bunch of 3n's, don't you? Does that make sense? You have 3n to the whatever 7 plus 18 is. 25, huh? 3n to 25? Yeah. We're done. Is that good? Why would it be wrong if I wrote it this way, guys? This is not correct. Why not? Yeah, the 25 would only be on the end. There'd only be 1 3 and 25 ends. And that's not the same as 25 3 ends. You know, 3n, 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 25 times. Right? A little different. Make sense on that? We good? So it's the same thing. We just keep the bases the same, add the powers. Huh? Question? Yeah.
For the last one,
Yeah.
with the parentheses,
Right?
you have to write that in there for the answer. Is that why you crossed out the other one?
Yeah, right. You have to, this is the answer. It's got to have the parentheses. If you try it this way, it'd be wrong. If you don't put the parentheses on, it's wrong.
Okay.
Math Excel will say no. Yeah, did you see why as well, logically? Right? Because that would only mean 25 ends, not 25 threes. Right? That'd be 1 3 and 25 ends. That's not right. It's 25 of the whole 3 ends. On that. Yeah, good. Good. All right. So yeah, so how about this one? Let me give you guys a plan to make this easier for you. So what I would do, for the first thing, whenever there are negative powers, which we have here, let them jump to the other side and become positive. First, do that first. Let that be your first action. So whenever you see a negative power in there, oh, and let me mention, other items stay where they were. So the other items stay where they were. What others? I mean the y. This he's not going to jump to the bottom because he doesn't have a negative power on him. In fact, what power does he have on him? Yeah, just a 1, right? There's nothing, like always, it's an invisible, positive, regular 1, huh? So he doesn't have a negative power. He's not going to jump, but the -7, y to the -7, that one's going to jump. So that one will jump to the bottom, and so we'll have y to the 1 over y to the regular positive 7. So far, so good? Is that making sense so far? We're not quite done, but so the first step is the negative powered items jump to the bottom and become positive. Then, does anybody already know, what do you do when you have, we know if you had powers side by side, like if it was y1, y7, you would add them up to be 8, huh? If you had that. What do you do when they're vertical, like they are here, when they're one over the other? You subtract them, huh? Do you guys know that rule already? That is correct. The answer is going to be y to the 6th on the bottom, because 7 minus 1 is 6, and that leaves nothing but a 1 on the top. And that's our final answer. So let me talk about that a little bit. So how do we get to that final answer? So again, the negative powered item jumps to the bottom and becomes positive. Remember, negative powers are unhappy where they're at. They want to jump to the side. Whereas the regular y, he's happy. He's just going to stay in the top. He doesn't have a negative power on him. He's not unhappy. He's going to stay right where he's at. But the negative power guy's unhappy. He's jumping to the bottom, becomes positive. And then whenever you have same powers vertical, same bases with powers vertical, you subtract. 7 minus 1 is 6. If the bigger power is on the bottom, then the answer is on the bottom. If the bigger power was on the top, the answer would be on the top. On that. Wherever the bigger is, that's where the answer is.
So would it be y, it would be 1?
Yeah, well, you know what? It's a good question. Let me say this in a way that's more clear. If I can erase that, you guys have hopefully got that down. If not, there's always the YouTube. Okay, so let me show you what this really means to just be extra clear. You don't have to write this out. But here's what it really means. It really means 1y on the top and 7 on the bottom, which you know, huh? 3, 4, 5, 6, 7. That's what it really, again, you don't have to do this. But just for extra clarity, isn't that what it means? And then wouldn't these guys cancel? And so what would be left on the bottom is the y to the 6, like we said. That's why we just subtracted. It's just a way of doing this quickly. And what's left on the top of that fraction? Nothing. What do we always do when the top of a fraction has nothing? Do we just call it blank over y to the 6th? You always put a 1. That's not something new, right? Think about like 2/6. What do we do when 2 goes into 6 3 times and there's nothing on the top? What do? You don't just go blank thirds. You go 1/3, huh? That's what we always do. I'm not doing anything new. I'm doing what we always do. When the top of a fraction vanishes, we always put a 1. Does that make sense? So you don't have to show all this. Just subtract the powers. You jump right to the answer on that. Question?
What if you get the -1?
-1. I don't have. There is no -1.
It's just your circle.
Yeah, I know what you mean. It looks like it, huh? Let me erase my circle to be more clear. Yeah, that's just y to the regular 1.
Okay.
Yeah, I see what you're saying. And so it's really a positive 1, so he stays up top. And the other one jumps down. Yeah, does that make sense then? So negative powers jump to the other side, and after they do, you subtract the powers. The bigger power's on the bottom, so the answer's on the bottom, and when the top vanishes, that's always a 1. All right. So r to the -9, r to the -3. Okay, so what do negative powers do? Jump. Well, no, don't do anything else. Don't let them interact. First, let them jump. That's always the first step, right? So I really encourage you, because if you start trying to do stuff with negatives, it's going to mess you up. just what do negative powers do? They jump. Do that first, and then they become positive after the jump. And then think about what's good.
Are they over 9? Or 4 or 6?
These are wise.
What you mean?
They only have the sets, they don't have like individual.
Yeah, wise. All right, so both these guys are negative, so they're both going down, huh?
So R3 over R9?
R to the plus 9, R to the plus 3, right? They both, on the last problem, only one of them was negative. So only one of them jumped down. The other one stayed up top, right? But this case, they're both negative powers. They both jump to the bottom and then become positive after the jump, right? That's what negative powers always do. Jump to the other side. They're negative. They're unhappy where they're at. They want to jump to the other side, become positive. I've got nothing on the top. What do you always do with nothing on the top? 1. All right, now, are these guys vertical or side by side? So what do you do when they're side by side? Add them up. 1 over R to the 12th. We're done. Does that make sense? That good? So the last one, they were vertical, so we subtracted them, huh? But when they're side by side, you add them. All right. It's kind of a weird one. So m to the 4th times m to the minus 4th. Try that one. And what's that? What's anything that's zero power? Remember about half an hour ago we were doing what?
That's
E
one.
to the 0.
No, I know, but I'm
4 minus 4 is 0.
Right, so right, right. Yeah, good. Oh, you're good. Yeah. All right, so there's a couple of ways you can do this one. What is that? So this is my encouragement. Negative powers. What did negative powers always do? Yeah, they're unhappy. Remember, they're unhappy. So he's jumping down. What about the other one? What about the positive 4? He's staying put. He's like, I like this job. I'm good here. But the negative power one's like, I'm out of here. I'm jumping to the other side. So the one of them stays in the top, the other goes to the bottom, and when it jumps to the bottom, it becomes positive. So notice they're both positive, really. Right? Is that good? The negative one jumped to the bottom, became positive. And now, what does that equal to?
0 M
1. Same thing over itself. Elephant over elephant. 1, right? Doesn't matter what it is. I don't need to do any fancy rules about powers or letters or whatever. Same thing over itself. That's 1. Isn't it?
That's a 2.
I would just say it could be anything.
So it wouldn't be
Okay.
M, it would be 1.
It would be 1 and not what?
M.
Right. Right. It's 1.
That's a 2-part problem.
Oh, is it?
Yes.
What do they want? Type an exponential form. Oh. Yeah, thanks. Thanks, James.
That's gonna be
Let's back up.
M to the 0 power.
Yeah.
Then
Yeah.
it'll be 1.
Totally. Yeah, so I guess they're making you go painfully slow. So yeah, thank you. Let me back up and do it what they want. Yeah, I didn't even know it's 2 parts. First they want exponent. All right, they're being real picky here. Yeah, okay. So let me go back to what did we learn a minute ago about when they're vertical? What can you do with the powers?
Subtract.
Subtract them, right? So it's 4 minus 4, 0, right? Is that good? Subtract the powers? So that's the answer they want here, like part A. And then part B, so that's like part A. And then part B, what is anything to the 0 power? 1, which we already knew because we just canceled them. By the way, there's your proof that anything to the 0 power is 1. Remember earlier we were saying, why would 0 power be 1? Because 0 power means same thing over itself. Right? Subtract those powers, that's how you get a 0 power. Do you see how that's true? Math isn't just making stuff up there. That's consistent with the rules. Right? Whenever you have the same thing over itself, that means 0 power when you subtract those powers, which we already know that thing's 1. So 0 power must be 1. It's got to be. See how math just follows the truth? That is what I always enjoyed about math, that they just follow the truth. Right? Whereas language, what's the rule with English language? I before E? Is that always true though? Except after C, but is that always true? Unless it's a rainy Tuesday and the moon is out, then you just do whatever, right? Yeah, received is different. That's just, and I'm not putting it down. You should study English. You should read and write well. It's very important. But nevertheless, English or any language, the rules just develop as people talk. People talk. Remember, ain't wasn't a word for a long time, and then people said ain't enough, and boom, ain't was a word in the dictionary, right? Language just develops as people talk. So there's no rhyme or reason, right? It's not consistent. Whereas math, it's pure truth followed out, right? It's always consistent. Yeah, so okay, so give that one a try, guys. So those are vertical, they're divided, really. So, and by the way, none of those powers is negative, so I don't have to jump anybody. They're all happy in their job. They're happy right where they're at. So what do we do with those powers? Subtract. And hey, is the bigger one in the top or the bottom? Because that's where the answer ends up, right? The bigger one's in the top, huh? So it's going to be 19 minus 5, in other words, 14. We're done. Good? You don't even need to show this in between step. You don't want to. Just 6 to the 14th. By the way, what if it had been the other way? What if it had been the bigger power on the bottom? I'll go, what if? So, 1 over, huh? Yeah, you'd still just subtract, but the bigger one's at the bottom, so the answer ends up at the bottom. The answer is wherever the bigger was. And if there's nothing on the top, we know that's a 1. Yeah, so dividing is always subtraction. That's exactly right. And if they're side-by-side multiplied, we would add powers, huh? All right, so try that one. So 18 to the third over 18 to the 9. There's no negative powers there, so I don't have to jump anybody. So just go ahead and finish it from there. So they're divided. So I'm going to subtract. Yeah, where's the bigger one, top or bottom? Bottom. So it's going to be 1 over something. Subtract the powers, 18 to the 6th. Good? That's easy for you? All right. Okay, so try that. So we have 5s to the 5th over 5s to the 15th. Same thing, there's no negative powers, so nobody needs to jump anywhere. We're just going to subtract the powers again. Where's the bigger one? It's on the bottom, so we know it's 1 on the top. Subtract them. Can I write it like that?
No.
Why would that be wrong?
You multiply.
Yeah, you got to have the parentheses, right? Yeah, because that other way it would just mean the 10 was only on the s, it wasn't also on the 5. You could, my 5s look like s's. It all kind of looks the same. Here we go, a little slower. So yeah, you got to have those parentheses because the 10 is on both of them. If you skip the parentheses, then he's only on the s. All right, you know. Okay, so it's c over c to the minus 2. Try that one. This one tricks people a lot of times. Let's see what you can do on that one. I'll give you a second. Feel free to talk it out with those around you. See if you're getting the same answer. This one can be a little tricky. All right, here's the mistake. Well, what power's on the top? 1, right? Here's the mistake I see a lot of people make during the semester. They'll go, well, it's just subtract powers, Mr. Heron. This is wrong. What I'm doing right now is wrong. They'll go, right, because vertical is subtract powers. It's 1 minus 3. That's c to the minus 2. And this is all wrong. This is all wrong. And we can't have negative power, so it's 1 over c squared. There we go. Wrong. What's wrong about that? What did they do that's wrong? Yes. Good. Good. Yeah, remember I said let negative powers jump. First. You'll be much safer. You'll be much, because negative powers are what? They're negative. They're unhappy where they're at. So instead, this guy wants to jump up. Doesn't matter left side, right side, whatever. Just let him go up somewhere, right? What about the one on the top? Is he gonna jump down?
No.
No, he's happy. He's like, I like this job. I'm a positive 1 power. I'm happy here. But the negative power, I'm not so happy. So he comes up, and they're both on the top, huh? The c to the 1 so this is all wrong. The c to the 1 stays on the top. The c to the minus 3 jumps up there with him. C to the plus 3. Now they're on the same level, so what do? They add. C to the 4 is the right answer. Huh. Now, what was wrong with that other way? Can't you do the subtraction thing? I mean, isn't that a rule we learned if you wanted to? You could, but you better be really careful with it. It's top minus bottom. So if you want to do that correctly, what you should do is go 1 minus minus 3, you see. Right? Because it's whatever's on the top, take away what's on the bottom. The minus 3 is in addition to the subtraction. So what does minus minus 3 do? C to the 1 plus 3. So yes, you can get the right answer if you're super careful doing that, but most people get messed up by the minus signs. That's why I'm suggesting it's safer for you to just let the negative powers jump first. That would be the easiest way to guarantee the right answer. All right. All right, so t to the minus 9 over t to the minus 4. Try that one. We have to, our final answer has to be positive powers. So make whatever your final answer is to be positive. We don't want any negative people in the end. No unhappy workers. Right. All right, so what do the negative powers do?
They jump.
And this time they're both jumping. They're both unhappy. So t to the 4 over t to the 9. They're both positive powers now. We good? Okay, and now they're divided, so we're going to do what with the powers? Subtract. Where's the bigger one? On the bottom. So the answer will end up on the bottom. 9 minus 4 is 5. Well, there's nothing on the top. There it is.
Why did you have like that instead of multiplication?
Okay, because this time they were both jumping. So on the last one, if you look back, yeah, let's compare. I think it's helpful to look back at the last one. On the last one, see how one of them was positive and the other was negative? They weren't both negative. So on the last one, only the bottom one was unhappy. Right? Only the bottom one was a negative power. So only he was going to jump. The top one was like, I'm happy. I'm not jumping anywhere. I'm staying up here. So the bottom one jumped up and they were together on the top, weren't they? Both positive. But on this one, this t to the minus 9 over t to the minus 4, they're both negative. They're both unhappy. They're both jumping on that one. Then they become positive, then you subtract the powers. Yeah?
So, what I'm going to ask you is to see if what I did was a common mistake. So what I did was, since we had to jump them and flip them,
Right.
I had put 1 over t over 4 and then over 1 over t over 9. Is that like a common mistake, or do you know why I thought that? Then I understood it when you did that.
Right. So you're saying you made it 1 over t to the 9 and 1 over t to the 4 like that?
Right.
Yeah, that's actually true. You're right. That's not a mistake.
Oh.
It's just not the easiest way to do the problem.
Oh.
That's a true, so you're remembering a true fact from math, probably from previous class or something. You're right. That's actually true. But it's hard. I could show you all the steps, but it's just going to be easier to just do what I'm showing you. That is true, though. That is another valid but more complex way to get there. All right. Let's... All right, so 5 to the second to the second. What happens, let me just write a rule for you. The rule is powers outside parentheses multiply powers inside parentheses. So this 2 and that 2 we're going to times. So that will be 5 to the 4th power. So powers outside parentheses multiply powers inside parentheses.
There's no power in there.
Then there's a 1 really. Right? If somebody just gives me 5 and just the power outside, there's really a 1 in here and they multiply, it'd be 5 to the 2. Right? Because everything really has a power. If it's not showing its power, it's an invisible 1. Is that good there? Does that make sense? Let's try another one. So we have a to to the minus 5 to the minus 6.
So would that be a positive 30?
Yeah. So powers, so again, the rule is powers outside parentheses multiply powers inside parentheses. So powers outside multiply powers inside. So negative, so all that's going to happen is these guys are going to multiply negative 5 times negative 6, positive, or regular, you don't need to show the plus sign, regular 30. And that's it, we're done.
So why would these wouldn't be from or negative exponents?
Yeah, if it ended up negative in the end, I would have flipped it. But the negatives vanished because two negatives multiply to be positive. Yeah, so when two negatives multiply or divide, they make positive. Yeah, if they'd hung around, I would have had to do a flip thing in the end. Yeah. Questions? Yeah.
So you only got to flip it if it's the end of the question?
Yeah, I know, because I said on the other ones flip in the beginning, huh?
Right.
Yeah, I wouldn't. Yeah, so I guess you could. Of course, you could do that. I'm just trying to show you the easiest way. You could flip them right in the beginning. That's going to be harder. So yeah, I'm just showing you what's easier. It's easier to just multiply because the negatives are going to vanish. Yeah. So different things are easier in different situations.
So if
All
you
those
have
rules
a
are true.
positive and then a negative, we're-
Right. So let's see if they give us one. All right. Let's try it. So we have a b to the negative 3. Yeah. So here we definitely should, right? Because notice we don't have really any powers inside the parentheses. I mean, there's ones, but nothing to speak of. So what? Well, yeah, actually, we could do that. Huh? There are ones. Let's go ahead and do that. So the a and the b, they both really have 1 powers, don't they? Right? When everything has an invisible 1, if it doesn't show any other power. So what does the power outside parentheses do? Multiply, multiply. So we get a to the minus 3. B to the minus 3. Is that good so far? I'm not done because I can't leave negative powers. Then I'm going to flip them. They're both going to go to the bottom, aren't they? So it'd be a to the regular 3, b to the regular 3 on the bottom. What's on the top? 1. So here's the answer.
And they would need to be separate like that, not A, B, parentheses.
Actually, that's right also.
Okay.
Like in other words, if you wrote this, that's the same thing, really.
Can you see what? Oh no.
Yeah, the multiple choice is right there. Yeah, but you're right. You're right. That's the same answer. These are two ways to say the same thing. On that. They just happen to go the other way. They'll just say or. Both are right. They went that way. Does that make sense then, guys? So again, the rule we're seeing here is powers outside parentheses multiply powers inside parentheses, right? So the understood 1 powers on the A and the B, the negative 3 multiplies both of them.
So what if you get a positive inside and a negative outside?
Yeah, so they would just multiply. So like if you had a squared to the negative 3 like that. So they would just times, that'd be a to the minus 6, right? Because positive times negative is negative.
and then you flip.
And then you'd flip. And it'd become positive 6. Make sense? Here's another example. All right. So, good. So powers outside parentheses multiply powers inside parentheses. And then you do whatever is needed based on the rules we've already learned. Okay, this one can trick people. Let's see how tricky. You guys have done pretty well. A little better than I'm used to. So, see if you can be tricky on that one. Give that a try. So we've learned the rule, right? Powers outside parentheses multiply powers inside parentheses. So see if you can follow that rule. Okay, so the powers outside parentheses do what? They multiply powers inside. What powers are inside?
1 and 4.
Yeah, don't forget about that 1. That's the trick. People tend to forget about that 1 there, and they'll just do 6 times 4. But you also have to do 6 times 1, huh? So it becomes 2 to the 6th, t to the 24. That's the right answer. See, that's so they forget about the 6 times 1 thing. Is that good? Is good on that? So powers outside parentheses need to multiply all the powers inside. And everybody has a power. If it's not showing its power, it's an invisible 1. Right, good? All right, try that one. So it's a to the 6th, c to the 9th, all to the minus 5 power there. All right, try that one.
Now, 1 over n to the 30th and n to the 40th. I think.
Okay, powers outside, multiply powers inside. A to the minus 30, c to the minus 45. Good so far?
Yeah.
And then what a negative power? We can't leave negative powers on. They're unhappy. And they're both unhappy. If one of them was negative, the other positive, the positive guy would stay up top. But they're both negative. They're both jumping down. So a to the 30, c to the 45 on the bottom of a 1. And we're done.
Oh, you wouldn't add those?
Oh, yeah, good question. Why wouldn't we add those? They're different. If they were both A or both C, yeah, we totally add them. But they're different. Good. All right. Inkle. All right, so try that one. So it's A to the minus 4, B to the 2, C to the minus 3, and we got a 2 power outside. So you know powers outside parentheses. The 2 is going to multiply all those powers inside. So do that first. That 2 is going to go boom, 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 right? Get A to the minus 8, B to the 4, C to the minus 6. So far, so good? And by the way, that's when the parentheses are. Have you noticed parentheses always drop off whenever something from the outside goes in? That's when you drop the parentheses, right? So parentheses are gone. All right. Now, can we just leave our answer like this?
No.
There's a couple of unhappy campers up there, huh? The negative powered items are unhappy where they're at. They want to jump. Who's going to stay put though?
Before.
The B, the positive. So the A and the C are jumping down, huh? So it'll become B to the 4th will just stay on the top. A to the 8th and C to the 6th will become positive on the bottom. And that's our final answer. Is that good? Good with all those rules? All right. All right, let's try that one. So 2A to the minus 4, B to the 3rd, all to the 3. All right, you want to try that one? Same rule. Powers outside parentheses, multiply, powers inside parentheses. So make sure you multiply all the powers that are inside. What am I talking about? Which power is invisibly there? Yeah, the 2 to the 1 power, huh? Don't forget that 2 has a 1 power. Right? Everybody has a power. Every number, every letter. So there's really a 1 power there. Right there. So boom, boom, boom. So it'd be 2 to the, not 6. What am I doing? 2 to the 3, A to the minus 12, B to the 9. That good so far, first step? Can I just leave the answer like that?
No.
Why not? What's wrong?
Unhappy camper.
Unhappy camper right there. He's like, I'm not happy. Jumping down. So the 2 to the 3rd and the B to the 9th stay on the top. The A to the 12 goes to the bottom, huh? Like that. That good? Not good? No good at all? Oh, it isn't quite good, is it? And then we can do something more with the 2 to the third, huh? What is 2 to the third? 2 times 2 times 2? So if they give you just numbers, you can work it out. That's 8, huh? So it's actually 8 b to the 9th over 8 to the 12. There we go.
Wait, why did you do that?
Because it was just numbers, it wasn't letters. Yeah, so if you just have a number to a number, you can actually work that out.
I don't think they want you to certify, right? Because 80 is different.
It says simple.
The other side?
Yeah, I think it's
No, it's.
Yeah, it says
no, it's
simplified.
not.
there it is.
Oh, I couldn't see that.
Okay, but here's the thing though, you got 8 negative 12, or you have 8 positive 12 underneath, isn't it supposed to be negative 12?
Well, it was negative, but then it jumped to the bottom. Remember when it jumps to the other side, then it becomes positive.
Oh, okay,
Yeah, remember they're unhappy where they're at, they're negative, they jump to the other side and become positive.
okay.
Is that all good? So if you just have numbers to numbers, go ahead and work it out.
I had the power right, but I kept the negative on the bottom.
This was some fraction stuff, but the rules remain the same. So c to the third over 3, all to the second. What rule am I talking about? There's a power outside of parentheses. So what do powers outside of parentheses do? Multiply what? Powers. Powers with powers. So carefully, that 2 is not going to multiply, well, it's going to multiply their other powers, right? So what invisible powers are really in there? There's a 1 on the 3. So the 2 goes boom, boom. Is that good? Powers with powers. So we get what? C to the 6th over 3 to the 2nd. Is that good so far? Powers outside parentheses, multiply powers inside parentheses. Now, on the bottom, it's just numbers with numbers, so we can work that out. That's just 3 times 3. That's just 9. C to the 6th over 9. And we're done. No negative powers anywhere. We don't have to jump anybody. Good. Okay, let's try this one. N to the 8th over 5 to the minus 3. Same rule. Powers outside parentheses multiply powers inside parentheses. And we have an invisible power, don't we? Invisible power here. Multiply, multiply. Good. Everybody good to there so far? Powers outside, multiply powers inside. Now, we got some unhappy campers. We got some negative powers. So what are they going to do? Going to jump. Both are jumping, so it's really just a big flip, isn't it? Yeah. This guy's going up, that guy's going down. Does that make sense? Since they're both unhappy, they're both negative powers. So they're both jumping to the other side. So it becomes 5 to the positive 3 on the top and 5 to the positive, or just regular, 24 on the, n to the regular 24 on the bottom. Is that good so far? With the numbers to numbers, we could actually work this one out, huh? 5 to the third, that just means 5 times 5 times 5. Calculator will tell you that's 125.
Now, which answer is this going to factor in?
I think it wants the last answer. 125 over into the 24. Yeah. Does that make sense, those steps I went through? Is that good? So again, power from the beginning, powers outside parentheses multiply powers inside. And then negative powers are unhappy, they both jump to the opposite side and then become positive. And then whenever you have numbers with numbers, just use your calculator. 5 times 5 times 5, 125.
So if that would have been an N on the top, then we would have subtracted those?
Exactly, because if the bases are the same, then we subtract powers vertical or add powers if they're side by side. Exactly, that's for same bases, huh? Right, but if they're different bases, we just keep them separate. That's right. That's right. Which is not bad. So that's a big number. 210 with lots and lots of zeros. What is that? 210 what? I think it's billion, isn't it? Right? Because if it was right here, if it was right there, that'd be million, wouldn't it? That'd be 210 million. So our number's 210 billion, right? Yeah, it's 210 billion. So it's just under the national debt, or it's actually only a portion of the national debt, isn't it? Isn't national debt trillions now?
Yeah, a little touch.
Yeah, yeah.
We're in the trillions,
Yeah. That's like only 1/10 of the national debt.
not even that.
Anyway, we'll just do the math and. All right. So how do we convert that? So let me tell you what scientific notation is first. So I'll just abbreviate it SN. Scientific notation. It means two things. Number one, it means decimal after. Whoops, it's kind of scribbly. Decimal after the first digit, or behind, the first digit. 2, times 10 to some power. That's what scientific notation means, first off. It's a way of writing numbers in a scientific format. So, all right, so what I'm saying is I'm going to take this 210. Well, by the way, where's the decimal right now on the 200? I mean, I know the 210 billion is not showing his decimal, but where is it really? At the end, huh? Right at the end, right? Like if I say, hey, the price for that whatever is $56, and I don't write the decimal, you know it's at the end, huh? Like a period in a sentence. If somebody forgets to put it on, you know it's at the end, right? Okay. So with that in mind, the decimal's at the end. Now, this is regular notation. Well, it's not called regular. It's called decimal, technically. So it's an E there. Decimal or regular, just the regular way of writing numbers or decimal way of writing numbers. Now we want to write it over here in SN, scientific notation. So it's 2.1. Right? See, that's what it said. Put the decimal after the first digit. So 2 is the first digit, then comes the decimal.
To the 11th, right?
Times 10, right? Times 10 to some power. Yeah. What power? Well, whatever power will tell the decimal to go back where he really belongs. Because he doesn't really belong after the 2. It's not really 2.1. Right? 2.1, that's not it. So if you put the decimal at after the 2 artificially, what power would you need to tell him to go back where he belongs? Well, 1, 2, 3, 4. Whoops, I'm getting all messed up. 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 places to the right. There's our answer. Does that make sense?
Okay.
So you just take the number and you rewrite it with the decimal after the first digit. But then you think, okay, that's not really where it goes. I got to give him times 10 to some power, which will put him back where he really belongs. So you say, well, if he was put here after the 2, how many places to the right? 11 places to the right. So you make it 11 power. So this is really the same number as that. It's just in different notations. It's like me saying 1 or uno. I'm saying the same number in 2 different languages. This is the same number in 2 different languages. Regular or decimal and scientific notation. Same number. Does that make sense on that? Scientific notation is useful for really big numbers because you don't have to say all those zeros. You just say 10 to the 11th. Okay. And some scientists, like astronomers with the stars way, way out there, they have huge numbers. Or zero, lots of.
It's really tiring having to write all those zeros.
Yeah, to move the decimal left is going to be a negative power. That's what we're going to have on this one. So I can't even see how many zeros there are there. What is it? Count.
7.
Yeah, don't count the one in the front, by the way. The one in the front doesn't matter. Just the one after the decimal. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6. So the one in the front doesn't matter. I'll put it on there, but who cares? 1, 2, 3, 4, 5, 6. 3, 4, 2. Okay, so that's regular. That's regular or decimal, it's called. Decimal notation. Now you want to write it in SN, scientific. So first off, where do you falsely, artificially put the decimal? after the 3, right? 3.42. You put it after the first digit that's not 0. I should have said that's not 0, but I think you knew that. So it goes after the first digit that's not 0, right? But if you put it here falsely, artificially, you would then need to go times 10 to some power to tell it to go back where it belongs. So you need to tell it to go back how many spots? 1, 2, 3, 4, 5, 6, 7. Back 7 spots, huh? Back. So negative 7 means go backwards. Go backwards 7. All right. Back 7. So if you need to tell the decimal to go to the right, that's positive power. To the left, that's negative power. Yeah?
So now this is the time we don't convert into multiplication because, or,
Oh, flip it, make a fraction. Yeah, no, they're not asking us to do that.
okay.
Yeah. So it's funny, different things are true, but they won't ask us to do them at different times. Yeah.
Which makes it confusing for everything.
Right. So you gotta pay attention to the instructions, because with the same question, they can ask you to do different things. Yeah. So want to learn to read those instructions on that. Yeah.
Does the 10 is over 10 or change the number?
What? Oh, yeah. Maybe it's going off the screen. Let me squeeze it in to be a little more clear.
Over like 10,
It's times 10 to the minus 7.
or you can over 10 or you change the number?
Oh, yeah, you're asking the same thing she is. Yeah, so the question's being asked by a couple of people, so let me address it. So a couple people say, no, Mr. Aaron, didn't we learn that you have to do like that? That's true, but they're not requiring that on this one. Does that make sense? You're right, negative powers do jump, but they're not making me do that. They're letting me just leave it like that.
But like this over number 10 like time 10 or over the time 10 or like you can change the number for like 5 or 7 like that.
Oh, no, it's always 10.
Okay.
Yeah, it's always 10. And the reason 10 is because when you multiply by 10, it moves the decimal. And we're moving the decimal. Because this is a decimal system. Dec means 10, right? Dec is 10. A decade is 10 years. Yeah, so when they say it's a decimal system, it's a base 10 system. Yeah. All right, so 100,000. So that's regular or decimal notation. So now change that into scientific. Where's the decimal on the 100,000 right now? It's at the end, like period in a sentence, right? If you don't see it, you know where it's at. It's at the end. Okay. And how do you tell it where to go? Or first off, I have to write the number with the decimal after the first digit, first off, right? Artificially. So what's that going to be? 1.0. Everybody good with that? Just put it after. You put it right here falsely. It doesn't really go there. But then you go, okay, no, but then times 10, it's always 10, to some power to tell it to go back where it belongs. How many places to the right? 1, 2, 3, 4, 5 to the right. Positive 5, huh? Regular 5. Is that good? Is that making sense? Scientific? Different way of... Let's see. All right, so 1 over, I think that's 10 million. 1 in 10 million. All right, so they want me to convert it times 10 to some power. Yeah, it is. It is. Yeah, let me help you with that. Have you ever thought about the fact that you guys know if you multiply 10 times 10, you guys know what that is, right? It's 100. Notice that here. Let me do this a little cleaner. You guys know 10 times 10 is 100. So 10 times 10 is 10 squared, isn't it? Notice the 2 and the fact that there's 2 zeros.
1 times 10 is the same.
So 10 to the third, then, is 10 times 10 times 10. 10 times 10 is 100, times another 10 is 1,000. Notice the power tells you how many zeros. So the power on the 10 automatically tells you how many zeros, right? So when I look at how many zeros are here? 7. So this is 1 over 10 to the 7th, but I can't leave it that way. But so far, so good? Does that make sense? Because there's 7 zeros. Anytime you have a 1, a number that's a 1 and a bunch of zeros, that's just 10 to the power of however many zeros. We can see that right over here, right? So that's 1 over 10 to the 7th, but they're making me not have it be a fraction. See how they're forcing my hand? They're saying, look, we want you to write it 10 to some power like that, not on the bottom, not a fraction. They're forcing me to. So what power could I put here that would be the same as making it jump to the bottom?
1 times 10.
Negative 7, huh? Because the negative 7 will make it jump and be 10 to the positive 7 on the bottom, which is what it really is. So that's our answer. We just put negative 7 in the box and we're done. Does that make sense? So you just look at the bottom and you go, look, there's 7 zeros on the bottom. So it's negative 7. Because the negative does the bottom, and the 7 makes the 7 zeros on the bottom. I was just kind of reasoning with you. You don't need to do this for this problem. I was just showing you the pattern. It is. It's just saying 7 zeros on the bottom, negative 7 power. That's what it's saying. Yeah, so looking back here, this one's negative because it went to the bottom. Does that make sense why that power was negative 7? Because it's 7 zeros on the bottom of the fraction. So if they just gave me something in the top, if they just said, hey, what's 7 zeros just regular, not on the bottom, it would just be 10 to the regular 7, huh? Make sense? But if they put them on the bottom, got to make that a negative power.
Any number in the fraction will be negative. A negative power.
Remember, negative powers make things jump to the bottom. Remember how we talked about that? Negative powers make it unhappy. Right?
Well, I'm just saying, like, anything that's underneath will just be a negative power.
That's right.
Okay.
Yeah, because negative powers make it jump to the bottom, makes it unhappy. That's right. All right. So let's try this one. Now we're going to go the other way. So now we're starting with SN, and they want us to go back to regular or decimal. So we're converting from uno back to 1. We're going back to regular. So how do we do that? We have 5.719. Let me give a little more room here. We have 5.719 times 10 to the, that's an 8, right? Minus 8. So we're starting with the scientific notation. And they want me to just go to regular. So what do? What is that negative 8? Remember, he tells the decimal to go back where he belongs. What is that negative 8 telling the decimal to do? Go right 8 or left 8? Left 8, huh? 1, and you're to the edge of the number. The other 7 jumps are going to bring in zeros. Does that make sense? We've got to jump back 8 places. The first jump gets you to the edge, and then the other 7, 1, 2, 3, 4, 5, 6, 7. They're going to bring in 7 zeros. 4, 5, 6, 7. And there's the decimal. So it's going to be decimal 7 zeros, 4, 5, 6, 7, and then 5719. 7 zeros.
Shouldn't it be over 1 or the 1 on top is a negative 8? Or...
No, yeah. No, okay. Yeah, so good. So everybody okay with that first off? So negative powers make you go left on the decimal. Positive powers go right. Now, a good question was asked. Now, wait a minute, sir. You just told us earlier that negative powers jump to the bottom and become fractions. Right. That's what they do in the fraction world. Now I'm telling you what they do in the decimal world. They do both things, depending on which world you're trying to go into. Does that make sense? It's just like me saying, wait a minute, you said 1 is uno, and now you're telling me 1 is un in French. Right, it's a different language. It is 1, it is un in French, it is uno in Spanish, right? So that's what I'm saying. Yes, negative powers, like if I go 10 to the negative 1, that is 1/10 fraction. It is also 0.1 decimal. Decimal goes back 1. So if you're talking decimals, the decimal goes back 1. If you're talking fractions, it flips it. We're talking decimals now. No more fractions. Does that make sense on that? So yeah, so in decimals, it just moves the decimal back that many places. So that negative 8 power tells the decimal to go back 8 places. The first jump gets you to the edge. The other 7 bring in zeros. 0.705719. That would be the regular decimal way of saying this scientific notation number. Good. Questions on that? All right. So 10 to the minus 2. Notice they say, give me a decimal. If they wanted a fraction, I would go 1 over 10 squared, huh? We already know that rule. That was the first half of this section. But they want a decimal. So how am I going to do that? I'm supposed to move the decimal back. You know what's weird on this one? They're not giving me a number in the front. Remember how scientific notation is supposed to have a number in the front times 10 to some power? They're missing the number in the front. They're messing me up. Everybody with me? You getting tired after an hour and a half of me just continually talking at you? Are we okay here? Because you got to hear this. This will probably confuse you if you don't catch this. So remember, scientific notation is supposed to have some number times 10 to a power, right? Isn't that what it's supposed to have? And there's no number in front here. So, what do I do whenever there's an invisible number missing? 1, an uno, an or whatever you want to call it. A 1. Put a 1 there, right? It's 1 times 10 to the minus 2. That's the same as 10 to the minus 2, right? That didn't change anything. And now 1, I'd like to see the decimal also. Where's the decimal on the 1? Well, it's 1.0, huh? So I need a decimal number, as I'm moving decimals, right? That's the same as 1. It's just a fancy 1. So do that and then follow the instructions. What is that power telling that decimal to do? Which way, right or left? Left 2 jumps. Let me bring it over here where there's room. 1.0 times 10 to the minus 2. He's saying, you go left 2. This means left to decimal, left 2, right? So take the decimal, 1, 2. The first jump gets you to the edge. The other one brings in a 0. So 1, 0. Does that make sense? That's the answer.
So you don't really need the 0 behind the 1.
Yeah, you're right. This is actually irrelevant, huh? Totally. 0.01's the same thing. Yeah, good observation. Is that good? Does that make sense? If there's no number in the front, just put a 1 like always. It's a 1.0. Move the decimal 2 back because of the negative 2 power. So 0.01. The last one will be super easy. These two were pretty challenging. There's a lot to them. All right, so now they want me to multiply 2 scientific notation answers. So we're working in the scientific notation world now. They want me to multiply 2 scientific notation numbers. Let me tell you the easy way to do this, guys. That is my job. Multiply the numbers in the front and add the powers. So multiply 5.1 times 6.5. So somebody have a calculator, what is that, 30 or something, 30, 31, 32, I don't know. $33.52? 15, thank you. 33.15, so multiply the numbers in the front, and then take the powers, 10 to the 6th, 10 to the minus 2. So I'm kind of doing the numbers in the front separately, and then the 10 power things separately. Now, we learned earlier today that when you have same bases multiplied, you don't actually multiply the bases, huh? Remember that one? What do? You just, the power, 6 minus 2, because they're side by side. Remember, same bases side by side. Technically, you add the powers, but adding the negative 2 subtraction in the end. 10 to the 4th, huh? Right? That good? And so our answer is 33.15 times 10 to the 4th. Kind of put it back together. Does that make sense what I did there? So I just took the out front numbers separately, multiplied them, 10 separately, and you don't actually, when you have the same bases, you just add the powers, but adding a negative is really subtraction. So we get that. Are we good to there? Is that making sense? Because this one has a special trick. Here again, I'm wondering if I've been talking at you too long. I'm doing the Charlie Brown teacher, the wah-wah-wah, because there's a little trick. Why is this? Notice they asked me to write the result in scientific notation. Is this scientific notation? Not quite. Almost. Why? What's wrong with him? Yeah, that decimal is supposed to be after the first digit. It's picky, isn't it? No, we can't. I mean, we multiplied it and it came out there. Well, you can. You can fix it. That's a little tricky. So this is the right answer, except the decimal's in the wrong place. It's supposed, remember, scientific notation, you're supposed to have the decimal must be after the first digit. Remember? It must be after the first digit. You got to put it here. So can you just move it there and it's all good? No. If you move that, you've changed the number, and you can't change the number. I mean, this is the number, right? It's 1. You can't say dos, right? You can't, when you change languages, you got to still be saying the same number.
But you can do 10 to the power of 5.
Well, let's think for a second. If I move, this is the real number. If I move the decimal left 1 spot, 33, whatever, becomes 3, whatever. By moving it left, did I make 33 become something bigger or smaller? Smaller. 33 became 3.
You have to take 1 off.
So if I make this part smaller, remember I can't change the overall number at all. It's got to be 1 uno. Can't be 1 dos. Right? So if I make this part of the number smaller, then to compensate so that overall there's no change, I got to make this part of the number bigger. So you got to add 1 to his power times 10 to the 5th. That's the same number written correctly. So that's tricky, isn't it? So if you make this part smaller, you got to make that part bigger. So really, you haven't changed anything.
To make that bigger, you got to reduce that.
Yeah, it's like a teeter-totter. If one goes up, the other's got to go down. So we haven't changed anything. We've just changed the look.
But I thought if you moved to the left, you.
It's not that. It's a special. It's not. Yeah, I'm doing a special maneuver. I moved this left, which made him smaller. Which means I need to increase him.
Because you went from 33.15 to a smaller number of 3.315.
Yeah.
So in order to pick that back up, you have to add the power to the bottom.
That's right. To pick it back up. It's a good way to say that. That's right. That's right. I know that's a tricky one. That is a tricky. All right, so here we are dividing 1.8 times 10 to the 8th divided by 1.2 times 10 to the minus 9. What I would do is just like I did in the last one. I would do the numbers separately and the 10 things separately. This time we're dividing though, huh? Not multiplying. So so just take your calculator, take 1.8 divided by 1.2, just hit the buttons on your calculator. 1.8 divided by 1.2. Is it 1 point? I think it's 1.5, isn't it?
Yeah.
1.5 times, now, what do we do with these 10 things?
We leave them out how they are.
No, you flip them.
Yeah, let me bring it over here. What have we learned about negative powers?
Off the top.
Unhappy. Now, the top one's happy, though. The 8, he's like, I'm good. I'm staying here. I'm not jumping anywhere.
Side by side.
But the negative 9, yeah, so they'll become side by side. They'll both be on the top,
Yeah.
won't they? Whoops, that off the screen a little bit. So yeah, they'll add to be 17 times 10 to the 17, and we got it. And this one's okay. This one's on. We don't have to do any patching. He's already in the right spot. Decimals after the first. He's good. If he wasn't, I'd have to do the same patch trick. You make him smaller, make him bigger. You know, if you needed to. But that one just naturally came out good. Is that okay? I know at the end here is a little trickery. And that clock's racing me. That's the story of my life. The clock always wins the race. Try it. All right, so this is a trick one also. So 7.8 times 10 to the minus 8 over 1.3 times 10 to the 14. All right, let's do the same thing. Calculator, you guys got it? What's that? Is that 5 or something? 6? What is? Just divide those in your calculator. It's just straight out 6. 7.8. Is it straight out 6?
Yeah.
Okay. Straight out 6. All right, now, here's the trick, guys. Okay, what are you supposed to do with 10 to the minus 8 over 10 to the 14?
Unhappy camper.
You just take the bottom.
Yeah, negative powers jump. Now, the bottom one's going to stay put.
Yeah.
Because the 14's like, I'm positive, I'm happy here, I'm not going anywhere. So we get 1 over, and we get 10 to the positive 8 down there. They're side by side, so it's at 22? 22? Yeah. So that's 1 over 10 to the 22. Good to there? But, is that a scientific notation format? Well, we got to fix it a little bit. That's 6 times, remember, you got to have the 10 on the level. So what do? What can I write here that'll make it the same as that?
Over 1?
Negative 22. Because that makes it jump to the bottom. It's got to be on the level like that. Is that good? Just make it a negative in the end, because that's the same. You good with all those tricks? I know those are tricky at the end there. I think we have one or two little. Pluto's not a planet anymore, right?
Yeah, it's been declassified.
Yeah. Pluto doesn't care. He's always what he was. But anyway, the mass of Pluto is a lot. The mass of the sun is way more. How many times the mass of Pluto is the mass of the sun? It's off the screen a little bit there. Give your answer in scientific notation. That's a weird question. So you know what you have to do? If I said, hey, this person has $600 and this other person has $200, how many times, more is this person's money? It'd be 3. You all know he's got 3 times as much money. So what formal operation do you have to do with the 600 and the 200 to get the answer 3? You got to divide them. When somebody says how many times, you got to divide to see how many times, huh? So my point in all that is we have to divide these. That's fancy talk for divide these numbers, please. That's what they're basically saying when they say how many times, right? So let's go a fresh screen here. So I scribbled all over that one. Well, let's do it. So we got to take the sun number over the Pluto number. 1.998, 10 to the 27 over 1.310, 10. Can I go dot, dot, dot? You can do it just like we did the last one, right? Do the numbers in the front, do the powers separately, and that one will be good, right? You just divide in your calculator 1.998 divided by 1.310, and then 10 to the 27 over 10 to the 19. You subtract powers, right? Because those are vertical. Was that going to be 8? Somebody got the answer to this part? How many does? They said round the nearest thousand. So 1.525.
Yeah.
1. So they said round to the thousandth. Do you guys know where the, and then times 10 to the 8th here? Thousandths means third place, huh? Yeah, so 1.525 times 10 to the 8th. That good? So when they say how many times, that's code for divide. The big one over the small one. Woo! 3. There's 23. This one?
No.
Well, I mean, that version of it? Yeah. Yeah, feel free to copy that down. All right. We have 5 minutes. All right, let's wrap up. Let me get you a good little quiz here. Okay. All right, that's a good one.
He went to university last. He's gonna have to worry about it now.